Welcome back to this teach-out on tornadoes. Last time we talked about the frequency of tornadoes. We talked about where they occur. And this time we're going to talk about outbreaks of tornadoes that have occurred in the past. Now in the United States we have had a number of large tornadoes happen. Notably here the 9 most deadly tornadoes over the past 50 years. Number 1 on the list is this phenomenal tornado called the Tri-State Tornado. As the name implies, it means this tornado started in the state of Missouri and passed across Illinois and all the way into Indiana. Now we cannot at this point tell you whether it was multiple tornadoes taking the same path or in fact one large tornado on the ground the whole length, the latter being fairly unlikely. Nonetheless, the path of destruction it caused in 1925 was phenomenal. You can see it started in Missouri and travels across we'll focus on Murrysboro. Now in Murrysboro, a town that looks like this today, has regrown from that time. But back then, and here's a street view now and overlay a picture of what this same street corner looked like after the tornado happened. And you can see that the devastation was just phenomenal. Hundreds of people died in this particular path of the tornado. The tornado was on the ground for over 100 miles. This tornado stands out as the most destructive tornado ever in American history. We have had such tornadoes occur also closer to home here at Michigan. One of which, in 1953, happened in Flint, Michigan. The so-called Flint Beecher tornado went through a path just north of Flint. Here in this image, I can point to the fact that Flint is here, the city of Flint is down here, Beecher is just to the north, along what's now I-75. The path of this tornado starts north and just a bit west of Flint and travels a path through just north of Flint to the east and caused total destruction along its path. This storm is an F5 tornado. Later we're going to talk about how we define the various Fujita scale F rankings of tornadoes. But let me just say that this tornado had a width of greater than a mile. And put in perspective, here at the University of Michigan, that would mean that the entire central campus would be inside the tornado. And that path then moving across Flint caused damage as it went, even though there were warnings at that time. Another tornado outbreak, which was famous, occurred in 1974, April 3rd and 4th. This is remarkable because in a 24-hour period, we had 148 tornadoes on the ground. Not all at the same time, and this map shows that the first tornado happened somewhere just outside of Chicago. The second one's further south in Illinois, and you can see a pattern on here, I think. And the pattern has that these tornadoes move more or less from southwest towards the northeast. But what's happening is that, say, this tornado number 13 here on the ground just north of Fort Wayne, moving towards Michigan, number 14 following the same path, individual cells are moving towards the northeast, but the whole line of storms is moving towards the southeast. And so this produced a tornado from southwest to northeast. Then there's another line of tornadoes, again, later on, near Fort Wayne, some more through Indiana. You can see number 35, 36 through southern Indiana. And these storms continued as the day went on. Notably, there was a set of tornadoes coming up the southern Indiana, just around Cincinnati, and this tornado struck Xenia, Ohio, and caused tremendous damage in Xenia, Ohio that day. You can see that some tornadoes even came up here just along the downriver area near Detroit. So these are storms which progressed over the course of the day through Kentucky. Again, more storms in Kentucky, down into Tennessee. And as we move into Tennessee, you can see that the storms continue. Number 90 here through Tennessee. And then we get some storms, number 101 and 102, through Alabama caused great damage in Huntsville, Alabama. And finally, this whole pattern of storms continues until the last one, 148, happens in North Carolina. These outbreaks of multiple tornadoes are produced because we have storm systems that we'll be describing shortly, and these storm systems can produce tornadoes, and the same tornadic storm can form and reform tornadoes as it moves. Now, as I've said before, to make a tornadic storm, you have to have just the right conditions in the atmosphere, and those very complicated conditions don't happen very often, thank goodness. But it's when you have those conditions and they're maintained over a long period of time, you can get outbreaks like this. That was 140 some odd tornadoes in a 24-hour period. Not to be outdone, here in 2011, we had another outbreak with some 361 tornadoes over about a 2-day period. Now, this was particularly remarkable because it produced a number of very strong tornadoes. One of them, and here's a video of that tornadic outbreak. Well, here we are, April 2nd and 3rd, and I'm going to let this play for a moment here. You can see that each red dot in here represents a different tornado through that month of April, a very active month here in 2011. And here we are on April 13th, and you can see more storms or more tornadoes are being formed. We're going to focus in a moment. There's some more, another outbreak of tornadoes around the 16th and 17th. As we get close to this period, then the next outbreak, let me just slow it down here and show. Here comes another set of storms. I'm just going to walk through this set right here. We're just over the 26th, and the storms are forming. You can see them back here in the Texas area. A tornado is formed here in Arkansas. You can see the line of clouds, thunderstorms along this path here that are going to produce this outbreak in Alabama. And these move forward here across the southern states. You can see tornadoes being formed all through Arkansas and Texas into Louisiana. And then as we approach Alabama, there's a big outbreak in Alabama, which occurs right there as storms start to break out in Alabama here on the 27th. All as part of a series here, one set of clouds forming the tornadoes on the 26th, and a whole new wave of storms the following day coming through Alabama and Tennessee, and storms all the way across the southern states here. We're going to talk later in this teach-out about what could produce a storm system like this, but let's just share for a moment what happens when you have an outbreak like this, which produced a number of extremely strong tornadoes. Here's a picture taken in Tuscaloosa of this F5 tornado approaching Tuscaloosa. You can see in the background its characteristic shape. It looks like a big wedge. These larger tornadoes, as I said earlier, can be about a mile wide. They're going to have a shape unlike the sort of skinny tornado you saw in The Wizard of Oz. These large tornadoes are going to be more wedge-shaped. The reason for that, again, we'll be describing the dynamics and the physics for what causes that a little bit later. You can see the kinds of damage a storm like this can cause, though, and it's remarkable. There was a house here. All that's left is the slab on which it was based. And the trees in the whole area here have been just ripped out. Whole swaths of well-constructed buildings have been destroyed by this tornado. You get a sense for the width of the tornado here. The whole width of this building structure, housing structure, has been destroyed by that tornado. Here, in fact, the ground itself, the sod has been sucked off the ground by the strength of these tornadoes. Later, again, we'll be describing what's happening inside these large tornadoes, but it includes not only high wind speeds approaching 300 miles an hour, it also includes an upward motion, which is in excess of 100 miles an hour. So it's not unlike vacuum cleaner inside these large tornadoes. Obviously, you don't want to be trying to outrun a tornado like that because it can easily destroy your vehicle. And this includes a school bus, which is fortunately there were no students in this school bus, but you can see how his body was just removed by the winds in this tornado. Now, so far we've described some of the bigger tornado outbreaks in the United States, but some perspective is needed here. Because when you think about the places where tornadoes are more likely to break out, this map shows that yes, the United States has more than its fair share of tornadoes. We have some over 1,200 tornadoes a year on average in the United States. But if you had to list the place in the world where the most deadly tornadoes happen, it wouldn't be the United States. The tornadoes occur elsewhere, like in Europe. We see maps of tornado frequencies in Europe, and you can see that in Germany there's a large number of reported tornadoes in Germany, but they also occur in Italy along the coastlines, in England, and in Scandinavian countries as well. They can occur in most countries, but the most deadly tornadoes don't occur in Europe either. They occur in a place you might not expect, Bangladesh. In Bangladesh, they don't get very many tornadoes a year. They might get 5 or so on average in the course of any particular year. But when they get a tornado there, the density of the population and the fact that they don't have many cellars, for example, to escape to, puts people at high risk. And we can see that when we list the 9 deadliest tornadoes worldwide, that Bangladesh shows up more often than not. Number 1, number 2, 4, 5, 6, 7 most deadly tornadoes that have ever happened worldwide happened in Bangladesh. And the number 1 in 1989, April 26, with something like 1,300 deaths from one tornado. We can look at Bangladesh, we can kind of get a sense for what's going on there, as we will talk about. To create a tornadic storm, you have to have a mix of just the right atmospheric conditions. One of those conditions is near the ground. You have to have warm, very humid air. And we get that from the Bay of Bengal here, where air can move up from the south into Bangladesh. On top of that warm, moist air, you have to have a layer of cold and dry air. And that, in this case, is air that's coming across the Himalayas, maybe from the north or west. So that combination does a few things. One, it creates an atmosphere that we'll learn is called convectively unstable. And on top of that, because of the winds moving in different directions, it's producing a shear vertically through the atmosphere. Winds are from the south in the lowest level, and maybe from the west above it, produces a shear between those two layers. And that shear, that implicit rotation, when convection begins, is going to get turned vertically, and that becomes the seed, basically, for the tornadic formation. So in Bangladesh, we've had a map here of many of the tornadoes that have happened in history through that country. Again, a heavily populated country. And of note was that storm we talked about a moment ago. That storm, which killed, we think, 1,300 people, was on the ground for about 50 miles from Dalpatur to Saturia. And over that path, it's a very populated region with little warning and little place for people to go. So Bangladesh stands out as a place of few but extremely deadly tornadoes on the world stage. That tornado went some 50 miles on the ground. It's, we think, about almost 1.5 miles wide. Again, imagine where you are now and think about what's 1.5 miles from you to get a sense of that. And it caused some 80,000 people to become homeless, in addition to the 1,300 who died. So while we have the most number of tornadoes in the United States, for reasons we will talk about, worldwide we are fortunately not number 1, at least, in the number of deaths from tornadoes. And a lot of that has to do with the skill of the National Weather Service in predicting storms, formation, and movement once they have formed. We've been talking about outbreaks of tornadoes in the United States and globally. In our next teach out, we're going to talk about what causes such tornadoes. What are the conditions which lead to tornado formation, and how does nature create such a monster as an F5 tornado?